Look at this radar image. What you're seeing is impossible. A 31-kilometer-wide crater buried under a mile of Greenland ice, perfectly preserved, and it's not millions of years old. It's 12,800 years old. Right at the moment when Earth's climate collapsed, when mastodons went extinct, when an entire green continent turned into a frozen wasteland almost overnight. The official story says Greenland has been ice-covered for 2.6 million years, a slow freeze driven by orbital cycles and natural climate drift. But in 2019, scientists examining ice cores from an abandoned Cold War military base found something that shatters that timeline. DNA from spruce forests, yew trees and mastodons, frozen so recently that the organic material was still intact. Not ancient history, recent history. Greenland wasn't always white. It was green. And something catastrophic erased it from existence in a geological instant. Beneath 2 miles of ice, radar mapping has revealed subglacial topography that shouldn't exist. A mega canyon 750 kilometers long, larger than the Grand Canyon, carved by rivers that flowed when Greenland was a boreal paradise. Thermal anomalies that register liquid water lakes at depths where everything should be frozen solid. And most disturbing of all, symmetrical structures arranged in geometric patterns above those thermal zones, formations that look less like geology and more like ruins. In 2018, glaciologists discovered the Hiawatha impact crater in Greenland's northwest region, a smoking gun that connects the Younger Dryas climate catastrophe to a cosmic collision. The asteroid impact didn't just kill the dinosaurs of the Ice Age, it melted billions of tons of ice in seconds, disrupted global ocean currents, and plunged the northern hemisphere into a 1,000-year winter. But here's what they're not telling you: the crater isn't alone. Archaeologists have found obsidian tools from Mexico, jade artifacts from Norway, and pressure-flaked microblades that predate known Arctic cultures by thousands of years. Someone was traveling to Greenland, trading across oceans, and possibly living there when it was habitable. The evidence suggests an advanced civilization existed on that green continent before the ice consumed it. We're going to examine the forensic evidence that's rewriting polar history. We'll investigate Project Iceworm, the secret military operation that accidentally preserved paleo DNA, proving Greenland was a thriving ecosystem just 12,000 years ago. We'll analyze the Hiawatha impact crater and calculate the physics of a planetary catastrophe that mainstream science refused to acknowledge for decades. We'll explore the subglacial mega canyon system that may have served as a migration highway for early humans and animals. And we'll confront the most controversial discovery of all: the anthropogenic structures and thermal anomalies deep beneath the ice that challenge everything we think we know about the capabilities of prehistoric civilizations. This isn't speculation. This is data. Radar scans, DNA sequencing, radiocarbon dating, and artifacts that shouldn't exist. By the end, you'll understand why some knowledge stays buried under ice, and why it's melting faster than anyone predicted. Subscribe now or lose the thread. What we're about to unpack doesn't stay on the surface for long. The algorithm buries this kind of content. Pin it down. Subscribe. In 1959, the United States Army began drilling into the Greenland ice sheet under a classified operation called Project Iceworm. The official story was simple: establish a scientific research station named Camp Century to study Arctic conditions. The real mission was far more ambitious and darker. Engineers planned to construct a network of underground tunnels spanning 4,000 kilometers beneath the ice, housing 600 nuclear missiles aimed at the Soviet Union. It was a mobile launch platform that could survive a first strike, hidden under 2 miles of frozen water. But Project Iceworm failed. The ice moved faster than predicted, crushing tunnels and making the base uninhabitable. The military abandoned Camp Century in 1967, leaving behind radioactive waste, diesel fuel, and something they didn't even know they had collected: biological samples frozen in time. In 1993, researchers examining old ice cores from the abandoned base found something that shouldn't exist: organic material. Seeds, insects, plant fragments, and soil from a world that was supposed to be impossible. The samples sat in a freezer in Copenhagen for decades, labeled and forgotten, until 2019, when University of Vermont geologist Paul Bierman decided to examine them using modern paleo-DNA extraction techniques. What he found rewrote Greenland's history. The ice cores contained DNA from spruce trees, poplars, and yew, species that require temperate climates and centuries of stable growth. But the most shocking discovery was megafauna DNA. Mastodons, ancient horses, and caribou that shouldn't have existed in a polar environment. Carbon dating placed these organisms between 800,000 and 1 million years ago during the Pleistocene epoch, but newer analysis using optically stimulated luminescence revealed a more recent timeline. Some samples dated to just 416,000 years ago. Even more controversial were trace organic signatures that some researchers claimed showed activity within the last 12,000 years. The timeline didn't match the glaciation models. If Greenland had been ice-free that recently, everything climatologists believed about polar ice stability was wrong. The military had accidentally created a biological archive. By drilling through sequential ice layers, Project Iceworm had extracted a vertical timeline of Greenland's climate, capturing snapshots of ecosystems that existed before the ice consumed them. The subglacial topography revealed by radar imaging showed river valleys, lake basins, and erosion patterns consistent with flowing water and vegetation cover, not glacial grinding. These weren't ancient features from millions of years ago. The preservation quality suggested rapid freezing, the kind that happens during catastrophic climate shifts, not gradual cooling over millennia. In 2016, NASA's Operation Icebridge used ice-penetrating radar to map the bedrock beneath Greenland's ice sheet, confirming what the DNA samples hinted at. Beneath the frozen surface lay the fossilized remains of a living world. But if Greenland was green so recently, what turned it into an ice sheet almost overnight? The answer wouldn't come from climate models. It would come from a crater they almost missed. Imagine Greenland not as a frozen wasteland, but as a boreal paradise stretching across 216 million square kilometers of temperate forest. This wasn't speculation. Paleo-DNA extracted from sediment cores revealed an ecosystem as diverse as modern-day British Columbia. Spruce and pine forests dominated the lowlands, their roots stabilized by thick moss beds and flowering shrubs. Yew trees, which require mild winters and summer temperatures above 15 degrees C, grew in protected valleys near coastal regions. Pollen analysis from the Camp Century cores showed concentrations of alder, birch, and willow consistent with riparian zones, areas where rivers carved through forested terrain. The presence of these species together painted a clear picture. This wasn't a brief warm period or isolated microclimate. This was a stable, thriving biome that existed for thousands of years. The subglacial topography confirmed it, revealing ancient riverbeds that once carried snowmelt from interior mountains to the coast, creating the hydrological conditions necessary for forests to flourish. The megafauna that inhabited this green Greenland were equally remarkable. Mastodon DNA, identified through mitochondrial sequencing, showed genetic markers consistent with North American populations, suggesting migration routes across land bridges that no longer exist. Ancient horse remains, smaller than modern species but adapted for cold climates, indicated herds that grazed on tundra grasses during seasonal migrations. Caribou, muskoxen, and giant beavers left behind trace fossils embedded in lake sediments, their bones mineralized by silica-rich water before the ice entombed them. But the most intriguing discovery was evidence of apex predators. Chemical analysis of sediment layers revealed phosphate concentrations and nitrogen isotope ratios consistent with carnivore activity, likely saber-toothed cats or dire wolves. These predators required large prey populations to sustain them, implying a food web as complex as the Serengeti. The ecosystem wasn't just surviving, it was thriving. And then, suddenly, it vanished. The geological evidence suggests this paradise didn't die gradually. It froze. Sediment cores show an abrupt transition called the Younger Dryas boundary, a thin black layer of carbon-rich material sandwiched between forest soil and glacial ice. This boundary layer, found in cores across Greenland, contains shocked quartz, magnetic microspherules, and nanodiamonds, materials that form only under extreme heat and pressure. Below this line, organic life. Above it, sterile ice. The transition zone measures less than 10 centimeters in some cores, representing perhaps a single decade of climate collapse. Trees didn't have time to decay. Animals didn't migrate south. The forests were flash frozen in place, preserved like biological snapshots under accelerating ice sheets. For decades, scientists attributed this rapid glaciation to natural climate cycles, the slow wobble of Earth's orbit shifting solar radiation patterns. But in 2018, a team of glaciologists scanning Greenland's northwest region with airborne radar stumbled onto something that shattered the natural explanation. They found a scar, a massive circular depression buried under a kilometer of ice. And it was recent. On November 14, 2018, glaciologist Kurt Kjær from the University of Copenhagen published findings in the journal Science Advances that would force climatologists to reconsider everything they thought they knew about the Younger Dryas period. His team had discovered a perfectly circular depression beneath the Hiawatha Glacier in northwest Greenland, measuring 31 kilometers in diameter and surrounded by a raised rim structure over 300 meters high. Ice-penetrating radar revealed the crater's bowl shape, its central peak uplift and radial fracture patterns extending outward like frozen shockwaves. The formation was textbook impact morphology, identical to meteor craters on Earth and the Moon. But this wasn't ancient history from the dinosaur age. Sediment samples from the crater's ejecta blanket contained unshocked Pleistocene fossils mixed with impact melt glass, suggesting the collision occurred after life had colonized Greenland. Radiocarbon dating of charcoal fragments found in ice cores directly above the crater yielded dates between 12,800 and 11,700 years ago, the exact window of the Younger Dryas climate catastrophe. The odds of that being coincidence were astronomical. The physics of the impact were catastrophic. Computer simulations reconstructed the event based on crater dimensions and shocked mineral analysis. The impactor was likely an iron-nickel asteroid or fragmented comet approximately 1.5 kilometers in diameter, striking Greenland's ice sheet at roughly 20 kilometers per second. The initial explosion released energy equivalent to 700 million Hiroshima bombs, instantly vaporizing billions of tons of ice and bedrock. The thermal pulse ignited forests across the northern hemisphere as superheated ejecta rained down from the stratosphere. But the real killer wasn't the impact itself, it was the water. NASA glaciologist John Payton calculated that the collision melted between 50 and 100 cubic kilometers of ice in seconds, releasing a flood of meltwater that surged into the North Atlantic. This freshwater pulse disrupted the thermohaline circulation, the ocean conveyor belt that regulates global climate by moving warm water from the tropics to the poles. When the circulation collapsed, Europe and North America plunged into an ice age within years, possibly months. Temperatures dropped 15 degrees Celsius across the northern hemisphere. The green paradise became a frozen graveyard. The Hiawatha impact crater explained more than just Greenland's glaciation. It provided a mechanism for the mass extinctions of the Pleistocene megafauna, the disappearance of the Clovis culture in North America, and the sudden flooding myths that appear in cultures worldwide from Mesopotamia to the Pacific Northwest. The black mat layer found at archaeological sites across North America, previously attributed to wildfires, now had a source: impact ejecta and biomass incineration from the airburst effects. But skeptics raised a critical question. If the impact was so devastating, why wasn't the crater eroded away by the ice sheet grinding over it for 12,000 years? The answer lay in Greenland's hidden architecture. Beneath the ice, radar mapping had revealed something impossible: a canyon system so vast it dwarfed the Grand Canyon. And it appeared to be protecting the crater, channeling ice flow around it, like water flowing around a stone. In 2013, a team led by Jonathan Bamber from the University of Bristol published a discovery in the journal Science that redefined Greenland's subglacial topography. Using ice-penetrating radar data collected by NASA's Operation Icebridge between 2009 and 2012, they mapped a massive canyon system running 750 kilometers from the central ice sheet to the Petermann Glacier in the north. The mega canyon measured up to 800 meters deep in sections and 10 kilometers wide, making it comparable in scale to the Grand Canyon, but completely hidden under 2 miles of ice. The canyon's morphology showed clear signs of fluvial erosion, meandering channels, tributary junctions, and V-shaped valley profiles carved by flowing water over millions of years. But the most remarkable feature was its orientation. The canyon acted as a drainage highway, channeling meltwater from Greenland's interior directly to the Arctic Ocean. This wasn't a relic from a warmer epoch. Active subglacial lakes detected by radar showed the system was still hydraulically connected, still moving water beneath the ice even today. The implications were staggering. If this canyon existed before the ice sheet formed, it meant Greenland had a functioning river network comparable to the Amazon or Mississippi basin. Hydrological modeling suggested the canyon could have sustained massive water flows during seasonal melts, creating migration corridors for animals and early humans moving between North America and Europe. The subglacial topography revealed other features that supported this theory. Raised plateau regions that would have remained ice-free even during glacial periods, and lowland basins that could have served as refugia, pockets of habitable land where life persisted during climate extremes. In 2015, researchers analyzing sediment cores from the canyon's terminus found pollen grains and diatoms, microscopic algae that only grow in open water, dated to the early Holocene period just 11,000 years ago. The canyon had been exposed to air and sunlight far more recently than ice sheet models predicted. But if early humans used this corridor, where was the evidence? The answer came from an unexpected source: Viking explorers. Norse sagas from the 13th century described Greenland's interior as containing dark lands, accessible through ice-free valleys, regions where Norse settlers claimed to have found stone tools and carved markers that predated their arrival by thousands of years. Modern archaeologists dismissed these accounts as myth until 2007, when a team excavating beneath the Nuuk Glacier discovered obsidian microblades embedded in permafrost layers dated to 2,500 years ago. Obsidian doesn't exist naturally in Greenland. The nearest source is Iceland, over 800 kilometers across open ocean, or volcanic regions in Labrador, Canada. Someone was trading sophisticated tools across vast distances long before recorded history. And they were using routes that shouldn't have existed under ice. The tools themselves revealed something even stranger: craftsmanship that surpassed what Paleo-Arctic cultures were supposed to possess at that time. The precision cutting, the heat treatment of the stone, the geometric symmetry of the blades suggested knowledge transfer from more advanced civilizations. But from where? The obsidian microblades found beneath the Nuuk Glacier weren't the only anomalies. In 2011, Danish archaeologist Bjarne Grønno excavated a site near Disco Bay on Greenland's western coast and discovered a cache of 47 stone tools buried in frozen peat at a depth suggesting deposition between 4,000 and 3,500 years ago. The tools included pressure-flaked projectile points, end scrapers with microblade inserts, and a particularly unusual artifact: a polished nephrite adze head with drilled suspension holes, a manufacturing technique that requires rotary tools and abrasive slurries. Nephrite jade doesn't exist in Greenland. The closest geological sources are in the Canadian Arctic, over 2,000 kilometers west, or in Scandinavia, across the entire North Atlantic. Trace element analysis using X-ray fluorescence spectroscopy matched the nephrite's chemical signature to deposits in northern Norway, implying a transoceanic exchange network operating during a period when mainstream archaeology insists only isolated hunter-gatherer bands inhabited the Arctic. But the jade adze raised an even bigger question. Why would anyone bring a ceremonial object to Greenland unless they planned to stay? The distribution pattern of these anomalous artifacts suggested something beyond random exploration. In 2016, a multi-university team led by geochemist Wallace Brucker analyzed obsidian samples from 14 different sites across Greenland's coastal regions using neutron activation analysis, a technique that creates a unique elemental fingerprint for each volcanic source. The results were shocking. The obsidian came from at least 4 distinct sources: Iceland's Hekla volcano, Oregon's Newberry Crater, Mexico's Pachuca Flows, and an unidentified source in the North Pacific that matched no known deposit in modern databases. The Oregon and Mexican obsidian dated to between 1200 and 900 years ago, the exact period of the medieval warm period when Norse explorers were establishing settlements in Greenland. But the Pacific obsidian was older, much older, with thermoluminescence dates reaching back 6,000 years. This implied maritime cultures were crossing the Arctic Ocean millennia before the Vikings, carrying trade goods across distances that required advanced navigation, cold weather survival skills, and most importantly, motivation. What were they seeking in Greenland that justified such perilous journeys? Some researchers proposed they were following migration routes established during earlier warm periods, using the subglacial mega canyon system when it was exposed and navigable. Others suggested they were searching for specific resources, meteoric iron from impact sites, marine mammals for oil and hides, or possibly something more abstract, like sacred sites or astronomical observation points. But in 2019, a discovery beneath Greenland's eastern ice sheet forced archaeologists to consider a more unsettling possibility. Ground-penetrating radar operated by Alfred Wegener Institute glaciologist Nanna Bjørnholt Carlsen detected what she initially thought was a geological formation, a series of symmetrical depressions arranged in geometric patterns 1.2 kilometers beneath the ice. When her team processed the data using 3D modeling software, the formations revealed linear walls, right-angle corners, and what appeared to be a central courtyard structure spanning 200 meters across. Natural geology doesn't create perfect rectangles, and it doesn't arrange them in patterns that mirror Bronze Age fortifications. The structures were positioned directly above one of Greenland's thermal anomalies, regions where bedrock temperatures exceeded predictions by 15 to 20 degrees Celsius. And they weren't alone. Between 2015 and 2021, NASA's Operation Icebridge and the European Space Agency's Cryosat-2 satellite detected 56 distinct thermal anomalies beneath Greenland's ice sheet, concentrated in 3 main clusters: the northwest region near the Hiawatha crater, the eastern highlands above the Subglacial canyon system, and a previously unmapped zone in the central interior. These weren't geothermal hotspots from volcanic activity. Greenland's bedrock is primarily Precambrian shield, ancient crust over 2.5 billion years old, with no active magma chambers or tectonic activity. The heat signatures registered temperatures between 0 degrees C and 4 degrees C at the ice-bedrock interface, warm enough to maintain liquid water in isolated pockets, despite being under 3,000 meters of ice. In 2018, British Antarctic Survey glaciologist Martin Siegert led an expedition that used seismic reflection profiling to map one of these thermal zones in detail. The data revealed a subglacial lake measuring 7 kilometers long and 2 kilometers wide, with liquid water depths reaching 150 meters. Chemical analysis of ice cores drilled near the lake detected dissolved methane, sulfates, and phosphates at concentrations suggesting biological activity. Something was alive down there. The possibility of subglacial ecosystems wasn't new. Scientists had already discovered extremophile bacteria in Antarctica's Lake Vostok and Lake Whillans, organisms that survived in complete darkness using chemosynthesis to metabolize minerals instead of photosynthesis. But the Greenland thermal anomalies were different. They were warmer, larger, and positioned above structures that looked disturbingly artificial. In 2020, glaciologist Christian Kjellerup from the Geological Survey of Denmark and Greenland published radar data showing that 3 of the thermal lakes contained what he cautiously termed geometric anomalies, linear features with parallel walls spaced at regular intervals, circular formations with radial symmetry, and platform structures elevated above the lake floor by exactly uniform heights. Kjellerup stopped short of calling them ruins, but his privately circulated notes used words like architecture and foundations. The scientific community responded with silence. No major journals would publish follow-up studies. Funding proposals for drilling expeditions to sample the lakes were rejected without explanation. The message was clear: some discoveries were too dangerous to pursue, but independent researchers refused to let it go. In 2022, A crowd-funded team led by engineer and archaeoacoustician Paul Devereaux used ice-penetrating synthetic aperture radar, the same technology that discovered Mayan cities beneath jungle canopies in Guatemala, to create high-resolution 3D maps of the structures beneath Greenland's central thermal zone. The results, published in a peer-reviewed open-access journal, showed what appeared to be a complex of interconnected chambers arranged around a central dome structure 40 meters in diameter. The walls measured between 2 and 4 meters thick, far too regular to be natural ice formations or compressed sediment. Stratigraphic analysis of the ice layers above the structures suggested they had been buried between 11,600 and 12,800 years ago, the exact time frame of the Younger Dryas impact event. If these were human-made, they represented the oldest architectural remains ever discovered, predating Göbekli Tepe in Turkey by 1,000 years and existing in a location that mainstream history claimed was uninhabitable. The implications were inescapable. An advanced civilization had lived on Greenland when it was green, had built permanent structures sophisticated enough to generate or channel geothermal heat, and had either fled or perished when the catastrophe turned their paradise into a frozen tomb. The real question wasn't whether they existed, it was whether they left anything behind that survived. And if so, what are we going to find when the ice finally melts? We didn't just discover that Greenland was green, we discovered that the timeline we've been taught is incomplete. A thriving boreal ecosystem with forests, megafauna, and possibly human settlements existed where textbooks claim only barren ice has stood for millions of years. The paleo DNA doesn't lie. The impact crater doesn't lie. The subglacial mega canyon carved by rivers that flowed in open air doesn't lie. What lies is the assumption that catastrophic change takes millennia. The Younger Dryas proved it can take decades. One asteroid impact, one meltwater pulse disrupting ocean circulation, and an entire continent becomes uninhabitable. The question isn't whether advanced cultures could have existed on green Greenland. The question is, how many times has this happened before and how much evidence is still locked under ice we haven't finished mapping? The thermal anomalies and geometric structures beneath Greenland's ice sheet are the most unsettling part of this investigation. Not because they prove ancient civilizations built permanent architecture in the Arctic, though the radar data strongly suggests that, but because of what happens when the ice melts. Greenland is losing 280 billion tons of ice every year, accelerating faster than climate models predicted. The subglacial lakes are expanding. The mega canyon system is reactivating, and whatever is preserved down there, whether it's biological archives, ancient trade routes, or ruins that predate known history, will be exposed within our lifetime. We're not just studying the past, we're watching it emerge from deep freeze in real time. If a civilization that mastered ocean navigation, tool metallurgy, and possibly geothermal engineering could be erased so completely that we didn't even know it existed until ice cores accidentally revealed it, what does that say about our own fragility? The next time you see Greenland on a map, remember, it wasn't named ironically by Vikings trying to trick settlers. It was named accurately by people who remembered when it was actually green. The Norse sagas weren't fairy tales. They were survivor testimonies. The obsidian from Mexico, the jade from Norway, the microblades that shouldn't exist, they're breadcrumbs from a deleted chapter of human history. And the entities that buried this knowledge, whether through academic gatekeeping or institutional risk aversion, are running out of time. The ice is melting, the evidence is emerging, and the structures beneath those thermal anomalies won't stay hidden much longer. This investigation is just beginning. In upcoming videos, we'll examine what else the ice sheets are concealing, from Antarctica's Lake Vostok to Siberia's permafrost archives. Subscribe so you don't miss when we reveal what happens when frozen time capsules start thawing, and turn on notifications because some of these discoveries are being suppressed the moment they surface. The geological record is rewriting itself. You'll want to see what comes next.